Lesson 712, Scaling Quantities. The DLT for the day is, by the end of the period, the students will use multiplication to scale a quantity. You're in class. The video you're about to watch is 7-16 to 7-19. Your homework for tonight will be 7-21 to 7-26. Okay, I think we're good. All right, let's begin. 7-712, Scaling Quantities. Dana is training for a bicycle race. He can ride his bicycle at 25 miles an hour. One day, when he had been riding for 3/5 of an hour, he had to stop and fix a flat tire. Wow, I can't read. How many miles had he ridden when he stopped? Okay, so let's review from yesterday's lesson where we had distance equals rate times time. So we don't know the distance, but we know the rate, which is his speed, which is 25 miles per hour. And then you have to multiply that by the time, and he was riding for 3/5 of an hour. So right now, if I ignore the labels, what is 25 times 3? What is 1 times 5? Good. Then how many times will 5 go into 75? So it's 15 miles. Now, another way you can look at it is we did a line diagram here, and he was riding for 25 miles. So then we divided it into fifths because 3/5. So look, 1, 2, 3, 4, 5, and I need 3 of those. What's 25 divided by 5? So each of these little segments is 5. And if I have 3 of them, there's your 15. So in my blank, I'm going to write 15 miles. Okay. Matt thought about problem 16 and drew the diagram at the right. Look at Matt's drawing and decide how he is thinking about this problem. So he went from 25 miles. What does this little dot right here mean, you guys? That's not a decimal. Good, it's a multiplication sign. So let's do 25 miles, and we're going this way, times 3/5, which is what we did in problem 16, so we should get the same answer. Okay. What connection is Matt making between finding a distance using a rate and time, as you did in problem 16, and using a scale factor with similar figures? Well, both have a distance of, both have a distance, have distances of 25 and 15 miles. I crossed that A out. Sorry, guys. How are the situations alike and how are they different? Well, they're alike because they both solve 25 times 3/5, which was 15. And how are they different? Well, in 7-16, 3/5 is, that's a 3, is time in hours. And in question 17, it's, oops, hold on. 3/5, sorry you guys, 3/5 is the scale, make it fit, factor. Okay, can you see that? Yeah. All right. Scoot this up. Scoot up quite a bit. Okay. In the two previous problems, 3/5 is used in two ways. First as time in the rate, and second as the scale factor. Okay, that's what we just wrote. Both of these situations resulted in an equivalent equation of 25 times 3/5 equals 15. How else could this be written? So if I use my portions web, so first we used it as a fraction, right? A fraction. Okay, so we used a fraction. Check that off. So now I want to write it as a decimal. So how do you write 3/5 as a decimal? You know what? They changed 3/5 to 6/10. So what would 6/10 as a fraction look like as a decimal? So it would be 25 times 6/10. I'm not going to reduce it. And we know that that already equals 15. And then, so we just did the decimal. So now we need to do it as a percent, excuse me. So then 6/10, if I wanted to do it as a percent, what does percent mean? Out of 100. So what are you going to multiply the bottom by? 10. So you have to also multiply the top by 10. So then this will be 25 times 60%. And this is also 15, because you know what? That is just 3 different ways to write the same problem. Here it is with a fraction. Oops, I messed this up. Let's rewrite this one. This one was supposed to be a decimal. 25 times, I'm so sorry, 6/10 equals 15. Okay, now we'll do it. There it is as a fraction, there it is as a decimal, and there it is as a percent. Sorry about that, you guys. Okay, are we good to go to the next slide? Okay, good. Okay, if you did not already find it, oops, oh yeah, there it is. If you didn't already find it, what percent would be equivalent to 3/5? Well, on the other side, we said it was 60%. Use this percent to write a statement in words and symbols that is equivalent to that. Okay. So 60% of 25 is 15. Because of means multiply. Okay. Use the idea of scaling to find the following values. Write an expression using either a fraction or a percent. Then find the results. So this one already gave it to you as a percent. So we probably want to use it as a fraction. But you know what I did? I did it easier. Let's change 90% to a decimal. What is that? 0.9. And then we're going to multiply that by 25. And if you take 0.9 and multiply it by 25, you will get 22.5. You can check that on the calculator if you like. Okay, this is a percent. Be careful. How would we change this percent to a decimal? No, it's not 0.8. It is 0.08 times $75. And if you multiply that, you will get $6. And then how do you change 25% to a decimal? 0.25 times 144 gives you 36. You can check all of those on a calculator later if you like. Okay. Josue, is it Josue? That's not Jose. Hosea went out to dinner at an Indian restaurant. The total bill was $38. She wanted to leave a tip, a 15% tip. if you use the idea of scaling to find the tip amount, what would she need to multiply by? Well, she would need to multiply by 15%. Okay, so 15% is it as a percent. But what would 15% look like as a fraction? What does percent mean again? Out of 100. So I'm going to do this, but you know what? I'm not going to reduce it. Okay? And then what does 15% look like as a decimal? Okay, but you don't have to have the 0 in front of the decimal. So does it make a difference which representation, fraction, or decimal that you use to solve this problem? It does not matter which one you use. Okay, so this is an opinion question. Which do you think would be easier? So in this blank, you will either write fraction or you will write the word decimal. The only way you're going to get this wrong is if you leave it blank. So how much would she leave for a tip? Show your calculations. So what do you want to use? You want to use the decimal or do you want to use the fraction? Okay, let's use the decimal because we can use our calculator. Okay, so 0.15 times, her bill was how much? $38? Okay, so how much is she going to leave for a tip? Go ahead and work that out. Okay, so you know as a tip she's not going to leave more than $38. You would never leave a tip larger than your bill unless like you're crazy rich, which none of us in the room are. Okay, so she's going to leave a tip of $5.70. If you got 5.7 on your calculator, you know you have to turn that into money. Okay, so it's not $5.7, it's $5.70. All right, so now she's feeling very generous and she wants to leave a 20% tip. So then how do I change 20% into a decimal? And her bill is still $38. So how much of a tip is she leaving now? Is it $7.6? No, remember we need to change it to dollars. $7.60. Okay. That concludes today's lesson. Oh, I hope I didn't cut. I'm going to preview this and make sure I didn't cut anything off. All right. So your homework, go ahead and start it. Question 21 to 26. Okay, bye for now.